Welcome back, students. We're going to be looking at section 4.4, practice problems for applications of linear systems. Now, we've already done problems number 1 through 5 in the previous video. In this video, we're going to finish out these practice problems by covering number 6 through 10. So let me go ahead and scroll up here until we get to number 6. All right, so we have a 40% dye solution is to be mixed with a 70% dye solution to make 120 liters of a 50% solution. How many liters of the 40% and 70% solutions will be needed? There's a lot of numbers in there, right? So we need to be careful about what we place where in our chart. The first thing I notice is that our two percentages that we're going to be comparing is the 40% and the 70%. So that's why I have them listed here. So I need to give them both a variable. So I'm going to do X and Y. And then I need to fill in my total box. Did they give us a total? Yes, they did right here to make 120 liters. So I know that that is going to be my total amount. All right, now what we need to do is take our percentages and turn them into decimals so that we can actually use them. So that 40% is going to become 0.40, and our 70% becomes 0.70. And they want us to make a 50% solution here, so that's what's going to go in this box, 0.50, when we turn that into a decimal. Now remember, we take column 1 and multiply it against column 2 to get our values for column 3. So x times 0.40 is going to become 0.4x. I'm going to go ahead and drop that 10 because it's not necessary. It's to the right and it doesn't add any value. It's just a placeholder basically. Now I'm going to do the same thing here. We get 0.7y, 120 times that 0.5 gives us 60. We now have what we need to make our two equations. So x plus y equals 120. That's our first one from that first column. Our third column gives us our second one. 0.4x plus 0.7y equals 60. I'm going to rewrite them over here. X plus y equals 120. And then I have 0.4x plus 0.7y equals 60. Looking at these, it would appear that substitution is going to be the simplest way to work through this problem. So what I'm going to do is isolate one of my variables from that first equation. And I think I'm going to isolate my x. So let me rewrite our equation here. I'm going to subtract y from both sides. I get x plus 0 equals negative y plus 120, which is just x equals negative y plus 120. Now that I have that x isolated, I'm going to write my other equation over here. 0.4 times, I'm replacing that x with the value that I found, the negative y plus 120. And then writing out the rest of the problem. Go ahead and distribute that. That becomes a negative 0.4y. 0.4 times 120 gives us a 48. And then write out the rest. Now we're going to combine like terms. That negative 0.4y and that 0.7y. We're going to combine those and get 0.3y. Now I can subtract 48 from both sides. And it was 0.3y plus 0 equals 12. Rewrite that out as 0.3y equals 12. Divide both sides by that 0.3. And I get y equals 40. I'm going to use that to find my other value. So x plus y equals 120. Plug in my y value. Subtract it from both sides. I get x plus 0 equals 80. So my x equals 80. Now we just need to test to see if these are in fact the true values. So I'm going to go back to my original 0.4 times 80, that's my x value, plus 0.7 times my y value, which was 40, and that should equal 60 if we've done everything correctly. 0.4 times 80 is 32. 0.7 times 40 is 28. 32 plus 28 is in fact 60. So we have done our problem correctly. So to write my answer, I would say 40% gives us that 80. We need that 80 to get the 40, or we need 80 of the 40%. Sorry, I'm struggling to get that thought out there. And then of the 70%, we needed 40. So this is our answer. Number 7. Mariana wishes to blend candy A selling for $1.20 per pound with candy B selling for $1.80 per pound to obtain 45 pounds of a mixture that will be sold for $1.40 per pound. How many pounds of the $1.20 and the $1.80 candies should be used to make the mixture? All right, so we've got two candies. We have candy A and we have candy B. So I'm going to use those letters for my variables. So I have A and I have B. I don't know how much I need of A and B. I just know that I'm going to have each of them. And what they want to make is a 45-pound mixture. So that's the 45 right here because they want a total of 45 pounds mixed between those two. Candy A cost $1.20 per pound. Candy B costs $1.80 per pound. And they want a total cost when it's mixed together to be $1.40. That was right here. They want their mixture to be $1.40 per pound. Now we need to multiply across so that we can get our third column. So we have 120A, 180B, and 45 times $1.40 gives us 63. Now we have our first column and our third column to create our equations. So I have A plus B equals 45, and I have $1.20 A plus $1.80 B equals $63. And I just noticed I didn't put my 0 there. So I'm gonna go back and add that. All right, so I'm gonna rewrite these over here. A plus B equals 45. And then I had the $1.20 plus the $1.80 B equals $63. So looking at this, I think if I isolate either the A or the B in that first one and use substitution, that's going to be the simplest route for this particular problem. So I'm going to do that. So A plus B equals 45. I'm going to isolate the A, so I'm going to move the B. I get A plus 0 equals negative B plus 45. So A equals negative B plus 45. That's what I'm going to use as my substitution for the other equation. All right, so I have $1.20 times negative B plus 45 plus $1.80 B equals $63. All right, now I'm going to distribute through. I get a negative 120B. $1.20 times 45 is 54. And then rewrite out the rest of the problem. Combine my B's and I get 0.60B plus 54 equals 63. I'm going to subtract the 54 from both sides. I get 0.60b plus 0 equals 9. 0.60b equals 9. Divide both sides by that 0.60. And I get b equals 15. So we know how many pounds of candy B we need, but we still need to figure out for candy A. So I'm going to take the A plus B equals 45. Plug in my B value that I found, which was 15. Subtract that 15 from both sides. A plus 0 equals 30. So A equals 30. So I need 30 pounds of A. Now let's double check and make sure we did get the correct answers. So 120 times 30 plus $1.80, excuse me, times 15 equals 63. So $1.20 times 30 gives me 36. $1.80 times 15 gives me 27. 36 plus 27 is 63. So we did the problem correctly. So candy A equals 30 and candy B equals 15. That is our answer. Number 8. I'll erase that a little bit. All right, so number 8 says, how many pounds of nuts selling for $6 per pound and raisins selling for $3 per pound should Kelly combine to obtain 60 pounds of a trail mix selling for $5 per pound? So this is going to be similar to the one that we just did, the candy one. So I'm going to pick my variables based on the items. I'm going to use n, actually I'm going to use a lowercase n for nuts, and then R for raisins. And they want a total combined weight of 60. So I'm going to put 60 in here. The cost per pound for the nuts is $6 per pound. The raisins is $3 per pound. But the combination is going to be $5 per pound. Now we need to figure out our column 3. We multiply across, and that gives us 6N, 3R, and 60 times 5 is going to be 300. Now we have our first column that gives us our first equation, N plus R equals 60. And our second equation comes from the third column. So 6N plus 3R equals 300. I'm going to write those over here. N plus R equals 60. 6N plus 3R equals 300. All right, last time I did substitution. This time I don't have any decimals or anything like that. So I think actually the easier route would be to use elimination, the elimination method. And I'm going to multiply my top equation by 6. Actually, I'm going to multiply it by a -6 so that we can get rid of our n's. So my new equation will be -6n minus 6r equals a -360. And then rewrite the other equation that I didn't change. Add these two equations together. My n's cancel out. I end up with a -3r, and then I have a -60 from that addition part. So I end up with -3r equals -60. Divide both sides by that -3. And I get r equals 20. So we need 20 pounds of the raisins for our combination. Let's do the next part. So n plus r equals 60. Plug in my r, so n plus 20. Subtract the 20 from both sides. I get n plus 0 equals 40. So n equals 40. So I need 40 pounds of the nuts. All right, let's double check. Make sure we did our problem correctly. So I have 6 times the n value, which was 40, plus 3 times the r value, which was 20. And hopefully that gives us the 300. So 6 times 40 is 240. 3 times 20 is 60. And we do end up with 300 on that side, which equals the 300 on that side. So we're good. All right, so let's write out our answer. So the nuts, we need 40 pounds. The raisins, we need 20. Number 9. Suppose 2 planes leave Atlanta's Hartsfield Airport at the same time. One traveling east and one traveling west. If the planes are 2,100 miles apart after 2 hours and one plane travels 50 miles per hour faster than the other, find the rate of each plane. All right, so I've already labeled that we have east and west is what we're dealing with. So for my variables, I'm going to use the letters E and W. The time that they give us is the same for each one. It says they both traveled 2 hours. So I'm going to put 2 here and 2 here. Now remember, the way we get our distance is rate times time. We don't know how far they have traveled. We know how far they are apart, but we don't know how far they have traveled in that 2 hours. So the way we're going to have to show distance is this rate E times the time, which was 2, and we get 2E. Same thing for west, and we'll get 2W. Now, for our first equation, we have 2E plus 2W gives us that total distance of 2,100. Let me rewrite that. 2,100. Okay, we just don't know how far each of them have gone. We just know they've gone a total of 2,100 on our distance. Now, how do we get our second one? Our second equation has to do with this part right here, where it says one plane travels 50 miles per hour faster than the other one. So we need to figure out which one we want to designate. And it doesn't matter which one, we're just going to pick one. I'm going to pick the one going east and say it's the faster one. Okay, and it's going, it says 50 miles per hour faster than the other one. So I'm going to say W plus 50. So if I add 50 to the plane going west, 50 miles per hour to that particular plane, then it will equal the speed that the plane going east was going. So that's going to be our second equation. I'm going to rewrite them over here. 2E plus 2W equals 2,100. And then this one, E equals W plus 50. Since we already have E isolated on this one, I'm just going to use substitution. That makes the most sense to me. So I'm going to plug that in here. 2 times W plus 50 plus 2W equals 2,100. Distribute 2W plus 100. And then rewrite out the rest of the problem. 2W plus 2W gives us 4W. Subtract the 100 from both sides. I get 4W plus 0 equals 2,000. So 4W equals 2,000. Divide both sides by 4. And I get W equals 500. So we now know the speed of the plane going west. Okay, we know its rate. So now let's look at solving for the other one, for E. So I'm going to take E equals W plus 50, plug in my W value, and I get 500 plus 50. So the E plane was going 550 miles per hour. That was its rate. But let's check it just to make sure. So I'm going to use the 2E plus 2W equation. So 2 times 550 plus 2 times 500 equals the 2,100. 2 times 550 is 1,100. 2 times 500 is 1,000. Add those two numbers together and we do get 2,100 equals 2,100. And we are correct. So the east flying plane was 550. So that makes it the fastest. And the west plane was 500. So that makes it the slower plane. Number 10. A boat takes 3 hours to go 24 miles upstream. It can go 36 miles downstream in the same time. Find the rate of the current and the rate of the boat in still water. All right, so the first thing I noticed is we have upstream and we have downstream. Those are the two items that we're going to be comparing. We also know that they traveled in the same amount of time. They told us it took them 3 hours to go both routes. So I'm going to go ahead and fill in my time, 3 and 3. But how do we fill in our rate? Well, we have the rate of two items. We have the rate of our boat and we have the rate of our stream, our current. So I'm going to let X be the rate of the boat. And I'm going to let Y be the rate of the current, the stream. And we have to demonstrate both of those when we write out our rate box here. So if it's going downstream, it's going with the stream. The boat's going to be speeding up. It's going to be going faster because the stream is helping it. So I'm going to have X plus Y. When it's going upstream, it's going against the stream. So the stream is going to be slowing the boat down. So I'm going to have X minus Y. Now we need to fill in the distance. They actually give us the distance for each of these. Upstream was 24 miles. So I'm going to put 24 in the upstream box. Make sure you put it in the correct box. Don't accidentally put it in the downstream. And then they told us it went 36 miles downstream. So I'm going to put the 36 here. Now we can actually form our two equations. So remember, rate times time gives us distance. So I'm going to have 3, which is our time, times our rate, X plus Y, gives us our distance of 36. The second one is 3 times the X minus Y gives us the distance of 24. These are our two equations. So I'm going to write that over here. All right, I need to distribute before I start working with these. So this becomes 3x plus 3y, and then 3 times 36 is going to give us, oh no, I don't have to multiply that times 3. That's not in the parentheses. I almost made an error there. All right, our next one is going to be 3x minus 3y equals 24. Well, now I notice that my y values are the same, but opposite signs. So if I use elimination, I can go ahead and just add my equations and get rid of my y's. So let's do that. So I end up with 6x plus 0 because my y's cancel out. 36 plus 24 is going to be 60. So I have 6x equals 60. Divide both sides by 6, and I get x equals 10. So the rate of my boat is 10, but I still need to find the rate of the stream, of the current. So I'm going to use, let's use the top one, the 3x plus 3y equals 36. So 3 times 10 plus 3y equals 36. That becomes 30. I'm going to subtract that 30 from both sides. And it was 0 plus 3y equals 6. So So 3y equals 6. Divide both sides by 3, and I get y equals 2. So the rate of my current is 2. Let's double check that though. So 3 times 10 plus 3 times 2 equals 36. That becomes 30. That becomes a 6. That is 36. And so yes, for the first one, it does work. Let's check the second one. We have 3 times 10 minus 3 times 2 should give us hopefully 24. So that's 30 minus 6. And it does. It gives us 24. So the two sides equal. So we're good. So our answer is the boat is 10. The current, since it's y, is 2. And that's how we would write our answer. Let's look at our Bible verse. I will lead the blind by ways they have not known. Along unfamiliar paths I will guide them. I will turn the darkness into light before them and make the rough places smooth. Isaiah 42:16. I hope you guys are having a great week, and I'll see you in the next video. Bye.